For this lesson, we're going to be looking at some properties of circles. So to start, we'll talk about a few definitions. First is a chord. So a chord is a line segment inside of a circle that joins 2 points on the circumference of a circle. So here's an example of a chord over here. I take 2 points on the outside of my circle and I connect the dots. That is a chord. Now, chords can be anywhere on my circle. They could be there. I could pick any 2 dots on the circle. So what about there? I connect the dots. That's a chord. I could have one over here, 2 random dots on the outside of the circle, connect the dots, and I get a chord. I can also have short chords too. I could have 2 dots on the outside of the circle, connect the chord. So there are loads and loads of chords. There's infinite numbers of chords on a circle, but you can just pick 2 random spots on the circle and connect them. Now the next one is the diameter, and most of us are familiar with the diameter, but the diameter is a chord that passes through the center of our circle. So if I look here, 2 points on the end, and if it passes right through the center, we get our diameter. The diameter is basically how wide our pizza is, right? So if this is a whole pizza, my diameter is here to here, right? I could also have a diameter from here to here. So when I cut my pizza and it goes right through the middle, that length of that cut is my diameter, right? So we know that our small pizzas have a smaller diameter than our medium pizzas, which is smaller than our large pizzas. Now, I just want to also mention our radius. The radius is half of the diameter. So I just take my diameter and cut it in half. So the radius is a point on the outside of the circle to the middle, right? So if I looked at my little slice of pizza, that would be the length of just one side of one of the slices. Now the next one is an arc. And an arc is a portion of the circumference of a circle that joins 2 points on the circle. So there's one over here. This is an example of an arc. And an arc is kind of like the measure of the crust of our pizza, right? So if this is a pizza here, the arc would be the crust. So just this little bit of crust in between these 2 points, that is our arc. Next is a segment. A segment is a part of a circle bounded by a chord and an arc. So this blue diagram over here is a segment. So I take my chord, so 2 points, connect the dots. But to make a segment, what I do is now I take the crust part of the pizza. So I'm making this semicircle shape here, and that's what gives me my segment. Now I could make a segment anywhere. I just 2 random points, connect them, and I then use the arc. So I could have done it that way. I could also have done it this way and made a really big segment, just like that. Now the next one is what's called a tangent. And a tangent is a line which intersects the circle at only 1 point. So here's a tangent line over here. And if we look at it, it only hits the circle once. So even if I got a microscope and I looked really, really close, it doesn't hit it more than once. It just touches the edge of the circle and continues on. So if I want to draw another one, I can go here, touch the circle once and continue on. They're truthfully a little bit challenging to draw just to get it touching at one specific point, but that's the idea. And they could be anywhere on the outside of the circle, right? Any line that's touching the outside and only touching it once. I made a little mistake on that other one, but they're a little tricky to draw. But that's the idea of a tangent line. Next is a secant. So a secant is a line which intersects the circle at 2 points. So kind of like a chord, the only difference is a chord ends here, and here, whereas a secant goes on forever. So if we see our secant line down here, it's like a chord, so we pick our 2 points and we connect the dots, but a secant line goes on forever and ever and ever. So it just keeps going forever. But it's similar to a chord in that we pick 2 points on the outside of the circle and we just connect them. Next is a sector. A sector is the area enclosed by 2 radii, which is the plural of radius, of a circle, and the arc that connects the endpoints. In other words, a sector is what we call our pizza slice. So if I look here, I have my slice of pizza. That's what we call a sector. So we have a radius, this is a radius, and another radius, that's a radius, and then we have the arc length. So we have the 2 sides of our pizza, and then we have the crust. That's the idea of a sector, right? So it's just our pizza slice, just a different name for it. Finally, we have what's called the central angle, and this is formed by 2 radii of a circle. In other words, if I look down here, my central angle is right here. Basically, it's the angle at the tip of my pizza slice. So when I make my pizza slice, this here is my central angle. Right? So it's that angle formed by my pizza slice. That's what the central angle is. So just a few definitions. These diagrams are very, very helpful as you go through. It's a lot of diagrams that can be challenging to work with. So just take a look at them to refresh your memory as we go through. Now we're going to look at a few specific properties. Circles actually have tons and tons of properties. We're going to focus on 6 of them, but there are tons and tons and tons of properties of circles. Now this first one we're going to talk about is that chords in a circle are equidistant from the center of the circles in equal length. So chords of equal length are equidistant from the center of the circle. So that's a bit of a wordy sentence, but here's what it means. So if I have 2 chords on my circle, AB is a chord, that's the pink chord, and then we'll make a green chord with CD. As it's more of a teal, but close enough. So if both of these chords, if the pink chord and the green chord are equidistant from the center, in other words, if the pink chord is the same distance away from the middle as the green chord, then the chords must be the same length. So if my pink chord is the same distance away from the middle of the pizza as my green chord, then the chords have to be the same length, no matter what. And this is because we're working with perfect circles. I know these diagrams got a little squished. It was just because they were pulled from another worksheet, but they will always be the same. Now, similarly, if I have chords that are equal length, then they have to be the same distance away from the center. So that is true as well. So if I know for sure that the pink chord and the green chord are the same length, if I made sure of that when I made them, they have to be the same distance from the middle. So that's the idea of that one. Again, one last time, if my pink chord and my green chord are the same distance from the middle, they must be equal to each other in length. Similarly, if we already know that they're equal to each other in length, they must be the same distance from the middle. Let's look at another property. So the line that's perpendicular to the end point of the radius of a circle is a tangent to the circle. A line that's perpendicular to the tangent of the circle, then that line must pass through the center. So this is a little wordy, so bear with me. So if I have my circle like this, Once I find the middle, and I'm going to do my best to make this the middle. There we go. So if I have a line that's perpendicular to a line that's going through the middle, that has to be a tangent. Now, when I say the word perpendicular, I mean that they hit at 90 degrees. So if I have a line that's perpendicular to this line going through the middle, this one here has to be a tangent line, which means it only touches it at exactly one spot. So again, if I have a line that goes right through the middle of my circle, if I have a line that's perpendicular to it, it has to be a tangent. I know here my drawing isn't great. This picture to the right is a little bit better, but it does help me to explain it to you when I draw it as I talk you through it. But if these two are perpendicular, it has to be a tangent. Now, the same thing backwards is true. If the pink line is a tangent, then it's 100% going to be perpendicular to the yellow line. Now for our third property. Two tangents can be drawn to a circle from a point outside of the circle. These tangents are equal in length. So when I take my two tangents and then I go and I connect them to a point far away, they have to be the same length. So I have my pink tangent here, tangent A. Sorry that the lines aren't super straight. And I have the green tangent here, tangent B. Now because they're tangent lines, they only touch at one spot. If I pick a point C, over here, it can be any dot that I just drew, then the pink and the green lines have to be the same length, just with the properties of circles. They just have to be. All right, so property 4. If two angles are inscribed on the same chord and are on the same side of the chord, the angles are equal. So that's a bit of a wordy one, so let me reword it for you. So we have two angles that are on the same chord and on the same side of a chord. So if I look here, I have some chords going on. So when I have a bunch of chords like this, if I have some angles that are formed, these angles have to be the same in each of these. They have to. So this one is a little bit confusing, but when I connect multiple chords, that means that those angles formed by those chords have to be equal. Just with the way our circles work, so when I draw some chords, it means that these have to be equal. Now for property number 5, if we draw a triangle inside a circle where all three vertices are on the circle and one side has to be the diameter. So first thing is all three vertices of my triangle, or all three corners or points of my triangle, must be on the outside of my circle. And one of these lines has to be the diameter. It must be. Then the angle opposite the diameter will be 90. In other words, if I have this situation, again, here's the situation we're dealing with. We have a triangle inside our circle. I'll draw a different one just so you can see something a little different. So we have a triangle inside of our circle like this. And the middle line has to be the diameter. So it's going through the middle of the circle. That means that the angle across from the diameter has to be right. In other words, this has to form a right angle triangle. That's the idea here. Now our final property, if a central angle and an inscribed angle are subtended by the same chord and are on the same side of the chord, the central angle is twice the inscribed angle. So that's a really wordy one. So let me break it down a little bit. So here is my pizza. So here's the center of the circle, or the center of my pizza. So if I have my pizza slice here, this is the central angle of my pizza slice. So I'm just going to label these edges of my pizza slice A and B. Now, if instead of going from A to the middle, we go A all the way to the other side and B all the way to the other side instead, we get another angle here. So I went from having this teeny slice of pizza like this, and instead I have this giant piece of pizza instead. So when that happens, this angle will be double this angle. Now this little weird symbol I'm drawing, that's a theta. That's often used to describe angles, but another way to think of it is with actual numbers. So let's say this one was 10 degrees. This big one would be double that, so 20 degrees. If the little one was 30 degrees, this one would be 60 degrees. We can also do it backwards too. So if this one was 50 degrees, this one would have to be half of that, so 25 degrees. So I think this one is a little bit clearer than the others. The wording is really challenging. When we write out these properties, we write them out in proper mathematical terminology, which can be very overwhelming, but once you see the diagram, it's not too bad. Okay, so let's do a couple of examples just to give you a better idea of what you can use this for. So the first one here, we want to determine the unknown angles using our circle properties. So here, this is like our property 6. So we have the ends and we have our smaller slice of pizza here, and that gives us an angle of 80. Now we extend this to a larger slice of pizza like this. So that means this one has to be half of the other one. So that will give us 40 degrees. And we're doing that using property number 6. Now for B, we have a bunch of chords going on. So I look up to my properties. This is really similar to, definitely property number 4. So that was the one that was telling us that all of these angles were equal. So that means if I have an angle of 47 here, that one has to be 47 as well. And then that one is from property number 4. Now the next one here, we're going to determine some lengths of some unknown sides. So here we have 25 and 45. Now because of our circle properties, we know that this here has to be a right angle. So that means that we have a right angle triangle. And from lesson 2.3, we know that we can use our Pythagorean theorem. So we label our triangle. Oops, sorry, I mislabeled my triangle with A, B, and then C. There we go. And we're looking for B. So we have A squared plus B squared equals C squared. A is 2.5. We don't know B yet, and that's okay. And C is 4.5. So now we just put those into our calculator. 2.5 squared gives us 6.25. We don't know B yet, so that can just wait. 4.5 squared is 20.25. Now we want to get that B all by itself. So we have to subtract by that 6.25 on either side. And that will give us 14. Now remember, we just want B, not B squared. So we have to square root both sides. And that will give us 3.7 centimeters. I'm just rounding to the same decimal place as those decimals in the question. Now for our last one, similarly, due to our properties, this has to be a right angle, the one across from our center of our circle. So we're looking for this side here. So we have A and B. So A squared plus B squared equals C squared. 9 squared plus 12 squared equals C squared. So that will give us 81 plus 144 is c squared. So we have 225 equals c squared. And remember, we don't want c squared, we just want c. So we square root it, and we get 15 is c. Now these definitely take practice. They're challenging, so try the practice questions to the best of your ability.